Welcome to Maico Vietnam.
In so many industrial settings, the risk of an explosion is a hidden danger. It's not always obvious, but if you get it wrong, the consequences can, well, catastrophic. That's why choosing the right equipment isn't just a recommendation, it's a critical safety mandate backed by law. Today, we're going to do a deep dive into explosion protection, and we're going to focus on how to select the correct ATEX certified fan for these hazardous areas.
So, here's how we're going to break it all down. We're going to start with the basic physics of an explosion. What makes things go boom? Then we'll look at how we classify different hazardous areas. From there, we'll cover the legal side of things, the practical steps for actually picking the right fan, and how that fan fits into the whole ventilation system. And we'll wrap it all up with the most important message: safety is never, ever optional.
Okay, first things first. If you want to prevent an explosion, you've got to understand exactly how and why one happens in the first place. And really, it all boils down to a very simple but very potent chemical reaction. And this is the core concept right here, the explosion triangle. It's famous for a reason. You see, for an explosion to even be possible, you need three things to show up to the party at the same time: a combustible substance, think gas, vapor, or even a fine dust; an oxidizer, which is almost always just the oxygen in the air around us; and, of course, an effective source of ignition. Take away any one of those three things and the triangle collapses. No explosion. It's that simple. When you get that dangerous mix of fuel and air, that's what we call an explosive atmosphere. And our entire goal with ventilation is to do one of two things: either stop that atmosphere from ever forming, or, if it does form, make absolutely certain there are no ignition sources anywhere near it.
Now, here's where it gets really interesting. It's not just about the substance being present, it's about its concentration. If you have too little of it, you're below the lower explosive limit, or LEL. The mixture is just too lean, it won't catch. On the flip side, if you have too much of it, you're above the upper explosive limit, the UEL, and the mixture is too rich to ignite. The real danger zone, the sweet spot for disaster, is right there in the middle. That's the explosion zone.
So this brings us to the fan itself. You see, a regular off-the-shelf fan is basically a box of potential ignition sources. The motor gets hot, a fan blade could hit the casing and create a spark, you've got electrical terminals that could arc, you can even get a buildup of static electricity. This is precisely why you can't just use any old fan. You absolutely have to use one that's been specifically designed and certified as ATEX compliant.
All right, so now we know why explosions happen. The next logical step is to understand the system that tells us where the risk is and what kind of risk we're dealing with. And this is all about area classification.
This table might look a little complex, but the idea is actually pretty simple. The zone classification is all about how often an explosive atmosphere is likely to exist. For gases, we talk about zones 0, 1, and 2. For dusts, it's zones 20, 21, and 22. So a zone 0 or zone 20 area means the risk is there pretty much all the time, which means you need equipment with a very high level of protection. The logic is simple, right? The bigger the risk, the tougher the equipment's safety features need to be. Next, we have to classify the actual substances, because not all fuels are created equal. It's all about how easily they ignite. Group 2A stuff, like propane, is relatively stable. But as you move over to Group IC, now you're talking about things like hydrogen and acetylene, which are incredibly volatile. They can be set off by a tiny, tiny amount of energy. The same idea applies to dusts. Knowing your substance group is non-negotiable for choosing the right gear. And finally, there's temperature class, or T class. Now think about it this way. You don't always need a spark. A surface that gets hot enough can be an ignition source all by itself. Every single combustible substance has what's called an auto-ignition temperature. The T class of a piece of equipment is a guarantee that its maximum surface temperature will never get close to that point. A T6 rating is the absolute strictest, making this a critical piece of the safety puzzle. Okay, so all of this physics and chemistry isn't just a bunch of good ideas. It's all written down into a very strict legal framework. This is not optional guidance, this is the law, and it dictates how this equipment is designed, built, and used all across Europe and many other parts of the world. At the heart of it all is ATEX, and there are two key directives to know. The first one is basically for the manufacturers. It puts the responsibility on them to design and build safe products. The second one, though, is for the end user, the employer. It says you, the operator of the site, have to assess your risks, classify your zones correctly, and then use the properly certified equipment to keep your people safe.
Now listen up, because this is probably one of the most important takeaways. You cannot just buy a certified motor, bolt it into a regular fan housing, and call it an ATEX fan. It doesn't work that way. The entire final assembled unit has to be tested and certified as one piece. That's the only way to guarantee that every single potential ignition source has been dealt with. And that certification involves what are called types of protection. For instance, a really common one for fans in dusty areas is type T. All that means is that the enclosure is built to be totally dust-tight. It stops any of the bad stuff from getting in, while also making sure the outside surface never gets too hot. So, we've covered the physics, and we've covered the law. But how do we connect those dots on the factory floor? Well, that's where the practical selection process comes in. Let's walk through the steps to get this right every single time.
At first glance, I know this nameplate can look like a bunch of random codes, but it's not. It's actually telling you a complete safety story. You've got the X symbol for explosion protection, the equipment group, the category that tells you the zone it's for, the specific gas or dust group like IIB, and the temperature class, maybe T4. Learning to read this label is the key to making the right choice. And the process itself is really methodical. Step 1, identify your zone from your risk assessment. Step 2, figure out the gas or dust group you're dealing with. Step 3, determine the required temperature class for that substance. And finally, step 4, you choose a fan whose certification on its nameplate meets or ideally exceeds all 3 of those requirements. This is no place for close enough. And this is exactly where fully certified products are so essential. Fans like these from Maico have gone through that whole rigorous process. They're designed, built, and tested as complete single units to ensure they're safe for their specific job, in this case for zones 1, 2, 21, and 22. Now, having the right certified fan is absolutely critical, but you have to remember, it's just one part of a bigger system. The real safety comes from smart ventilation engineering. Here's a great example of a primary strategy: dilution ventilation. The whole idea is simple. You bring in enough fresh air to constantly water down the concentration of the hazardous stuff. You want to keep it way, way below that lower explosive limit we talked about. If you do that, an explosive atmosphere never even gets a chance to form. It's also not just about moving air, it's about how you move it. An effective cross-ventilation system, where you strategically place your supply and exhaust points, makes sure you don't have any dead spots in the room where dangerous gases or dust can just sit and build up. You're systematically clearing out the entire space. And that brings us to our conclusion. Honestly, this is the single most important message from our entire discussion today. Let me be perfectly clear about this. In these kinds of environments, choosing the wrong fan or an uncertified fan is not a small mistake. It is an error that can directly lead to a catastrophic failure. When it comes to certified equipment, there is simply no compromising. So if you only take one single thing away from this explainer, please let it be this. In hazardous areas, safety isn't just a good idea, and it's not optional. It is mandatory. And that means using only fully certified ATEX fans that are rated for your specific application. Look, this is a complex field, and getting it right is absolutely paramount. So if you have any doubts at all, or if you need expert help designing a safe ventilation system, the best thing you can do is consult with specialists. Thanks for your time.